Right, a few questions on page 270 of 18.1 where we have a bit of problem solving attitude about them. So ABCDE is a pentagon made up of three similar triangles. I could use that. In other words, triangle ABC is mathematically similar to ACD, which is mathematically similar to ADE. That's the end of it. So they're right angle triangles, so I can do trigonometry on it. I'm told that AB is 10. I've got to work out AE in the end. There's no way of going straight from this triangle to this triangle here. Impossible. But if I know AB and 30, I can work out the length AC. And if I know the length AC, I can work out the length AD. If I know the length AD, I can work out the length AE. I can do it using three or four different trigonometry calculations, or I can do one trigonometry calculation and then try and use similar triangles to actually play with the ratio and work out AE on its own. I may do both ways just to prove that it works. But anyway, I've got to work my way towards AE, that length there. So first step, let's try and work out AC. Now I've got a 30, I've got an adjacent, because it's next to the 30, I've got to work out the height. So I'm working out a load of heights here. So that's a height and of the triangle ABC. It's not the height of triangle ACD, however. It is in fact the adjacent of triangle ACD. So whilst I'm playing, I've labelled it height there. It's only height relative to this first triangle. So anyway, adjacent height is cosine, isn't it? So here I go. The cosine of 30 degrees is defined as the adjacent, which is 10, divided by the hypotenuse, which we're going to call AC. Why not? So to get AC on its own, we're going to go 10 over cos 30, and let's try and make it fit here. So 10 divide cos 30, well, that's what I've done there, rearranged it, you see it, equals 11.57. So let's just go to 1dp, 11.5. That's very reassuring because I've just worked out the hypotenuse, which is the longest length, and the 11.5 beats the 10, so I'm really happy I've got that right. Let's just do a couple more like this. So let's get rid of that height now, and I'm going to write in the actual answer. So this length is 11.5 centimeters. You see, just keep going round and round. I can now use this as the new adjacent length of this 30 degree in the ACD triangle, work out the new height, just keep going. So let's just do a second one now. Cosine of 30 equals the adj over height, which is not 10, it's 11.5, isn't it? 11.5 all over the height, which is called AD. So AD is going to be 11.5 divided by the cosine of 30, and we get the answer right now. So 11.5 divided by cos 30. I'm not going to keep showing the calculator, I'll just get on with it. 13.3. So there we go. It's gone even bigger for the simple reason that I've now calculated the new hypotenuse. So that's 13.3. Let's just write it in there. 13.3. Now I'm going to get it in my final step. I've got now the new hypotenuse, which is length AE. I've got the new adjacent of this angle, of this triangle ADE, and I'm now going to work in this region here. So here I go again, still 30 degrees. The cosine of 30 degrees is defined as the adjacent side, which is 13.3, divided by the hypotenuse side, which is the one we want, AE. Rearrange it. So AE is going to be 13.3 divided by the cosine of 30 degrees. Let's get our answer now. So 13.3 divide cos 30, and that gives me 15.35, call it 15.4 to 1dp. 15.4, and these are all in centimeters, 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 centimeters. Now I could have gone 11, 10 and 11.5, worked out a ratio and just multiplied up appropriately. I don't want to do that. I'm very happy just to leave it like that, practicing with our sine, cos and tan. In this case it's been cos all the way, so that's one way to do it. And there's your final answer, 15.4 to 1dp. Alright, let's just turn over, see what we've got. Right, here's a standalone question. This is question 6. It says a shed roof has sloping sides at an angle of 30 degrees. So there's the shed roof there. Each edge is 3 meters long. Work out the width of the shed, which is x. Very, very easy, really. Now, please note I don't have a right angled triangle, but this trigonometry only works if I have a right angled triangle. Therefore, I will create one by bisecting this top isosceles triangle here and calling it right angled. Well, that's now perfect, because what I've got here, I've got an adjacent to the 30 degree and the hypotenuse. So I'm going to call this an adjacent, and that is the hype. So what I'll do is work out the length from here to here, and then just multiply by 2, because it's the same each end, isn't it? So I'll make it fit in this little white space here. So I've got, let's have a look, the cosine of 30 degrees is defined as the adjacent divided by the height, which is 3 meters. So the edge is going to be 3 multiplied by, let's make it look like an M, 3 multiplied by the cosine of 30 degrees. Pick up my machine. So 3 cos 30 equals 2.598. That's 2.6 meters, I think. Very good. I'm glad it's less than the height. 2.6 is less than the longest side 3, so I've got it right. That's meters. So I've got 2.6 there, and I've got 2.6 right here, from there to there. Therefore, x is going to be 2 lots of 2.6. I don't need a machine for that. That's going to be, maybe I do, 5.2 meters. Yeah, that's it. Right, easy, isn't it? So that's the first example. We've had a triangle that wasn't right angle, but we've created one by dropping a perpendicular straight through the line, that dotted line there. Dead easy, isn't it? Right, next one. This is question 8, problem solving questions. Really, really nice. So Davey's making some trestles. So he's basically got like a, I don't know, sandwich board menu there, rope. So anyway, here's the design: hinge 40 degrees, 90, 90, rope, wood, the floor. He wants the trestles to open at 40 degrees. Yep. The horizontal rope support needs to be fixed 90 centimeters from the hinge. I've got 90, 40, 90 and rope. How long should the rope be? Essentially, I've got a triangle like that. Alright, I've got a 90 there, I've got a 90 there, this is in centimeters, as is that in centimeters, and I've got 40 degrees there, and I've got the rope across there, and I do not have a right angle. Oh dear, what am I going to do? Very simple. I play with half the triangle. I've got this, I drop a perpendicular line straight down the middle, and there's my 90. So let me work down here now. So I've got a nice slim little triangle there. I know this is going to be 20 degrees because I've cut in half. I know this is still 90 centimeters of length. I know this is half the rope. Let's just call it X for the sake of calling it something. So there we go. I've cut this trestle right down the middle like so. Oops, not very good, but anyway, that's what I've done. I can now work out some mathematical stuffs. What have I got then? I've got X is opposite the angle 20, and so that's the op, and the longest side opposite the right angle I've just created is going to be the hype. So op and hype is sine. Yeah, so here we go. The sine of 20 degrees is defined as the opposite length, which I've called X for short, divided by the hypotenuse length, which is 90 centimeters. That's 90. So X is going to be, take it over and multiply, 90 multiplied by the sine of 20 degrees. Pick up my machine. 90 sine 20 comes to, there it is, there's my calculation, 30.78. Well, we're going to call that 30.8, aren't we? So 30.8, and that will be in centimeters. Of course, that's only half of it. Let me label that in blue. So that's 30.8. That is also 30.8 because it's the other half of the rope. So rope length is going to be 2 lots of 30.8. So 60s, this will be 61.6 centimeters in length. Let's just check that. So I've got a calculator still in my hand. Yeah, that'll do fine. That's it. Dead easy. That's an application of sine, cos and tan trigonometry to a real life situation. How long must the rope be in order to fulfill the conditions of the design of this set of trestles? So that's that, and I'll stop the video now and look at 18.2 quite soon.